Alright guys, so in this video we're going to be learning how to integrate using a technique called U-Substitution. We're going to learn that just with the first example here. If you have integral of 2x times x squared plus 4 to the 7 dx, you're going to put u as a substitution, so you let u equal x squared plus 4, which is just this part. And how you determine what you let u equal to, like how do we decide to let u equals this? Well, to be honest, you have to just look at the whole integral over here, and you have to think what when you do the u substitution, what substitution that when you take that derivative would that equal this part. So when you do a substitution, you have to think what blob over here, when you take the derivative, would result in the derivative. That result is going to equal this part, this 2x dx. So you see here this part, and to be completely honest, that just takes, you have to do hundreds of examples until it just becomes second nature. It just takes a lot of practice till you can kind of just eyeball this integral, and you'll see that you have to let u equal this part over here, because x squared plus 4, if you differentiate that, that's going to be du equal to x dx. That part becomes u to the 7. This part becomes u to the 7 because u is x squared plus 4. And then you just write du here because du is 2x dx, and that was the remaining part. So it's pretty simple from here. After you set up the integral, you just integrate, becomes that, and then the final step, you just input back what you substituted. So you have u to the 8 over 8 plus c. So you just write 1 over 8, and then this is, u was this part over here, so u equals x squared plus 4, 8 plus c. We're going to move on to example number 2 over here. You have the integral of x over x plus 2 to the exponent 1 over 4 dx. So, and I just rewrote that here. It's completely the same thing as this. So right here, we're going to let this part equal u. Just ignore this part for now. I'll get to why I wrote that after. Just so you let u equal x plus 2, which is this u over here. That's going to be this. So you're going to substitute u for this x plus 2 part. And you differentiate u, which is going to be, so obviously you got to differentiate both sides. U is du now, and which is going to be equal to dx, because derivative of x is 1 and derivative of constant is always 0. And then let me try to explain why we let u equal x plus 2. It's because when you derive that, u equal x plus 2, you get du equal dx, so that part. And then this part, well, you're thinking, what does x equal? Well, you can rearrange this equation. Becomes u minus 2 equals x. So x, now you get u minus 2. This part becomes u minus 2. So you have this part. X becomes, according to this rearranged, becomes u minus 2. And that was just this part over here. And then you have x plus 2 to the exponent 1 over 4. So that becomes, since we let u equal x plus 2, that becomes u to the 1 over 4. And then you have du over here, because this dx part, we said dx is equal to du. So that becomes du. So anyway, the important part is this u substitution. Like, how do we know to let u equal x plus 2? It's because once you do that, that becomes du dx, and this, you get this rearranged, and it just all works out if you substitute it all back in. Honestly, you just gotta do lots of practice examples until you can kind of just see like what you have to let u equal to until all these x plus whatever to the x1 whatever dx, all the x terms can be substituted back in with u. So just keep doing a lot of examples. That's the best advice I can give you. So anyway, we get u minus 2 divided by u to the 1 over 4 du. So you just integrate that. What I did here is just this obviously u to the 1 over u to the 1 over 4. So it's just using the exponent laws, you just do this part over here. That just becomes u to the 1 over, sorry, u to the 1 minus 1 over 4. Minus, now we gotta do the second term. So it's minus 2 over u to the 1 over 4. So that becomes this over here. It's 2u to the minus 1 over 4, because it's at the bottom here. And du. And you just do some arithmetic here. 1 minus 1 over 4 comes that, and then this part stays the same. And this part here, we're just integrating here. It's used to the simple integration. I'm not going to go over it. You know, minus 2 is, yeah, it's do it. And then you just substitute back in here. This is the important part. You substitute, when you get this line over here, you substitute u back in. So u is equal to x plus 2. So you just put x plus 2 over here, x plus 2 over here, then you have a constant here. So, you know, the important parts in both example 1 and example 2 here was this part, the u substitution. U substitution. Then you differentiate both sides, du equals this, and you get du equals this, and in this example you have to rearrange this over here into that, so that you can have something to replace this over here as well. So hope that kind of explains it in the simplest terms. If it doesn't, just leave a comment explaining what you guys don't understand, and I'll try to explain it. But this should be pretty simple, clear.